So what I'm going to be talking about today is AI and exposing an AI as an API. I'm going to do that by using spam as an example. But before I get into it, let me introduce myself. My name's Hilton. I work at DataStax. We've got a booth just over there. If you haven't been to see the guys, please make sure you do. Through my talk, I'm going to cover a little bit about spam, how AI could help with spam. I'm going to talk about the AI that I did, specifically machine learning, specifically deep learning. And then we're going to talk about how I exposed that through an API. And I think the most interesting part of my talk will actually be the last part, where I talk about some interesting things that I discovered along the way. I looked at one of my online email accounts just before coming up on the stage here, and I noticed that I've got close on 200 spam messages today just in that one account. Who else gets spam here? Actually, maybe an easier question. Who does not get spam? Really? What's your secret? Gmail. Well, you are getting spam. They're just filtering it. Yeah. Okay. So spam is a big problem. And today, spam is not just in email, it's in text messages. Frankly, it's in phone calls now. But email is a huge communication medium to this day. The stats on spam, the numbers that are up on the screen here, 85%, that's the maximum for 1 month in 2021. And that equated to roughly 122 billion email messages in 1 day. Spam. 122 billion spam messages in 1 day. Now, my talk is not about the evils of spam, but it's interesting to get these numbers. You know, in light of some of the security issues that have been happening in the market recently, one interesting statistic to talk about there is the scams and fraud being at 2%, of which identity theft is about half of that. So only about 1% of spam out there last year was related to identity theft. Incredible, quite a small number. Most of it is in advertising. I guess adult-related content might be a big part of it. But the revenue model is there for the spammers. So I wanted to look at how could I apply machine learning to this problem. Now, one little comment about this. This is not a product. This was just an experiment. So it's not something that I would go and productize or put into production today. But I wanted to look at how can I apply machine learning to the problem of spam filtering. And to do that, I need to do two things. Number one, I need to train an AI model. Number two, I need to expose that model as an API. And I needed to learn some tool sets to do that. My background is in operations, IT operations management, and data, machine learning. These are slightly new things, so I had a steep learning curve. I took 2 data sets that are curated by the University of California. And those 2 data sets I prepared using some tools we'll talk about on the next slide. And then I fed those through, I trained a machine learning model. We'll talk about that in the AI section. And then I exposed that as an API. One thing that is important, I think, with any of these things, if you're going to take data and get value out of it, you need to constantly improve the quality of your data. And with a machine learning model, what does that mean? That means I need to constantly retrain the model on more up-to-date data so that the inferences or the predictions that the model make are better, of higher quality. And to do that, I added a whole section to my project, and I used one of our products at DataStax, the database, to store that data. So let's talk about the tools I used. Now, just like this slide shows, tools are important if you want to, cut your best friend's head off or chop down a tree. A lot of these tools are, I don't know, a Gatling gun, not my first tool of choice, but Python is a good language. I like Python. Who here uses Python? Most of us. In fact, one of the other talkers today asked that exact same question. And it seems that Python is a language of choice for data science. Along with that is Jupyter. And I'm going to ask again, who uses Jupyter? Jupyter notebooks. Yeah, quite a lot of us. I had never used Jupyter notebooks before this project. So first came across them about 4 months ago, and I am a convert. I love them. I love the way that they work. I love the fact that I can mix documentation and code in one document and execute that code in the document and share that code and share that document with other people. I also found that when using different cloud providers to execute machine learning training, that they all do that using Jupyter notebooks. So when you know Jupyter, you're one step ahead of the curve. The machine learning library I used was TensorFlow. TensorFlow can be a bit hard to work with, so there is another open source project called Keras, which acts kind of like an interface to TensorFlow. It does all the hard TensorFlow work for you, so you can work at a higher level. For the API, I chose FastAPI, and I saw there was another project here today, another talk was given on Nearmap, who are also using FastAPI. And FastAPI is great. A couple of things I like about FastAPI. It runs in Python, so I don't need to go learn a whole new language. It also automatically generates API documentation, open API documentation, or Swagger back in the day, by analyzing the code that you write using Python hints. For the database to store the results of my predictions or the results of my inferences, I chose DataStax Astra DB, which if you'd like to know a lot more about, come and see me down there after the show, but after my talk. But otherwise, let's suffice to say it is a serverless, high-performance database as a service hosted in your cloud provider of choice, and it's a model where you pay for what you use. You never manage infrastructure, you never need to install or maintain software. It's a database as a service, or more likely a data platform as a service, and you pay for what you use. You pay to read data, you pay to write data, and that's it. Moving on, let's talk about the AI. Start with the AI. So this is the workflow that I used to follow when I decided to do AI. So there's a couple of primary phases in this. There's initially preparing the data. Then we get into splitting the data. I'll talk a bit more about that. Training the model, and then making predictions based on my model. So the raw data I spoke a little bit about already, 2 datasets from the University of California. I chose those primarily because they're available. I didn't want to have to search too much to find a publicly available, labeled set of data. Now, when we talk about labeling data in the context of machine learning, when I train a machine learning model, I'm sure most of us know this here because we're all at a data engineering conference, but for those that don't, if I want to train a model, I need to give it examples of the data and a known result of that data. Now, in the case of spam, is it spam or is it not spam? So if I get a message, call 9115643 for a super discount on a new phone, is that a spam message or not? I need someone to tell me yes or no, and then feed those known results into the AI model that's training the model. It's one form of training. So we need to label the data. These data sets that I used are already labeled. So they were available, I chose them. Once I have those data sets, I then need to prepare the data. And to do that, I need to extract all the words out from each of the messages and create profiles on the words, and then arrange the data into training sets where we have the message and is it spam or is it not spam, what we call X, Y training sets. An X set of data and a Y set of data. The features and the labels in more data scientific terms. Then it comes to splitting the data. What are we doing when we split the data? When I train my model, I need to feed in some of the data for the algorithms to process and some of the data to test my predictions. So some of it is used to train the model, some of it is used to verify the model. So I split the data into two separate data sets. And then I go through the machine learning process of training my model. Now, there are many different types of models. There are recurrent neural networks. There are concurrent neural networks. The network type that I chose, or the layer type that I chose in TensorFlow terms, was LSTM, long short-term memory. The reason I chose LSTM was because LSTM operates on series data. Think about it this way. A picture is a single image. A movie can be thought of as a series of images. A regular convolutional neural network might be good for working on one image, but the minute I have a series of images and I need to work with feeding back data across the length of that time series, long short-term memory models have a good result. Okay, then I go through and I train the model. After I've trained the model, I need to deploy it and I need to expose it to new data. In the case of spam, what does that mean? It means that someone's going to send a message, I'm going to receive the message, the mail server's going to say, is this spam, yes or no, and give me an answer. Each time that happens, I get a prediction or an inference. Based on that inference, I'll either accept the email or not accept the email. But what I also want to do is store the message I received in a database along with what my model predicted, spam or not spam. And later on, go back and improve the model through the feedback loop where I monitor the model and I feed it back to the beginning. So what I'm doing there is taking all that saved data from production use, giving it to someone to label with, yes, this message is definitely spam, or no, this message is definitely not spam, and then feed it back into the model and retrain the model. That looks after the AI. Next was the API. So having a good, accurate model is one thing. Being able to use it in real time is another thing. And in the case of email, I need to be able to, for every email message that comes in, compare the message to my AI model, my machine learning model, and get a result. The easiest way I could think of to do that in real time, on demand, is through an API, because then the mail server can talk to the API, but so can other processes. Any process that wants to compare a message, is it spam, is it not spam, can use this API. So here we can see a little diagram that shows the data flow through the API. The mail server sends a request to the API with the message. The API passes that off to TensorFlow. TensorFlow looks at my trained model and says, this is spam or this is not spam, sends the result back to the API. The API stores all of that in my Astra database for data model improvement later on, and then sends a result back to the mail server. And all of that happens within a couple of milliseconds. Normally when I give this talk, I do have a live demonstration, but in the interests of time, we're not going to do that today. So let's talk about some of the things I learned. Jupyter is one thing I learned about in this project, and like I said before, I came to really like Jupyter. If you haven't tried it, give it a go, especially if you work in Python. It does work in other languages. So I'm a convert. Been using it for 4 months. I use it a lot now. And like I said before, part of my project was to compare using different cloud providers' machine learning services to understand how they compare from a cost point of view, from a speed point of view, and compare that also just to doing it on my Apple MacBook. I've got a fairly new MacBook. It uses the Apple Silicon, the M1 processor, and I wanted to see how does that stand up against Google, Amazon, and other machine learning systems. So I did that comparison. That was very interesting. The other thing we spoke about is storing the results from each of my predictions in a database. I chose to do that in Astra database, but this to me is the most interesting slide. This is the comparison of the timing. Now on this slide, shorter is better. So the shorter it is, the faster it did the training. My data set had about 200,000 samples, and I trained it 5 times. I chose an epoch of 5 with a batch size of 32. For those who do machine learning, that's just a little bit of what size batches we send to the training, to TensorFlow, and how many times I run it through to improve the quality. So I ran it through 5 times. This timing is in seconds and refers to 1 epoch. How long did it take to run the data through once? What's interesting here, the bottom one is AWS SageMaker Lab. It's not really part of AWS, but they call it AWS. It's a little bit outside. You have to request access to it. And the reason there is no dark blue line there, the light blue refers to CPU-based training. The dark lines refer to GPU-based training. The reason the SageMaker Lab does not have a GPU line is because in 1 month of trying, I could not get access to a GPU. Every time I clicked, I want a GPU, it said none available. Go figure. But their CPU was still faster than everything else, so win-win. The one above it is AWS SageMaker, the paid version. So if you've got an AWS account and you pay for your SageMaker access, that's the next one. Their GPU was the fastest outside of SageMaker Lab. Their CPU, not so great. Google Colab, from my perspective, Google Colab was the easiest to use, far easier to use and get an account and get access than on AWS, but not quite as performant. And then my Mac M1. Now the CPU on my Mac M1, the light blue line, that did all right, not bad for a laptop. The blue line, that would be going somewhere over there to circular key if we could draw it out. It's that long. The number on it is not 100 seconds, but 20,000 seconds. And the reason for that is explained in this slide. With a Mac M1, if you're trying to do machine learning on your Mac M1, should you use a GPU or should you not use a GPU? Well, it depends what you're doing. If you're trying to do basic reduction layers, use the GPU. It's an order of magnitude faster. If you're trying to do a regular convolutional neural network with 20,000 samples, the timing is up there, maybe not. And if you're trying to do what I did, the LSTM, definitely not. The reason being that the TensorFlow library for the Apple Silicon is not yet optimized. I'm hoping very soon that it will be, and then this will be a different story. Right now, if it was up to me, what would I do? Who would I choose? I'd probably keep doing it on my Mac for small data sets. For big data sets, I'd probably choose the free version of AWS SageMaker. That's it for my talk. Thank you very much for your attention. Please do come and see us over at the DataStax stand a bit later on. And if there are any questions, I've got a minute or 2 left. Any questions?
How do you do CI/CD with your machine learning models, and any approaches to like testing and continual improvement?
That's a good question. For this project, seeing it was more of an experiment, I didn't even approach CI/CD. But if I was going to be doing that, to deploy the model to the API, the step to do is after you train the model, the code that's trained in the model, in a CI/CD model, would upload that to a data store somewhere, probably GitHub would be a good place, And then when you deploy the API, you deploy the 3 files that make up the model with the API. So I would include it in my Git library for the API. That's how I would approach that.
Thanks so much, Hilton. Maybe one last round of applause. Thanks very much.